velocity of 70 miles per hour in the north 45 degrees east direction. What are the actual speed and direction of the airplane? So let's draw ourselves a picture. Let's just start with a regular coordinate plane. We've got north, south, east, and west. All right, the airplane is traveling at north 30 degrees west. So you start with whatever letter is listed first. So north is started first, or listed first. So we start on our north line right here. Then we go however many degrees in the direction of the second letter. So we're going to go 30 degrees towards west from north. So the 30 is going to go right here. Start with the first letter. You go however many degrees towards the second letter. And the degrees go closest to the first one. Okay. All right. So let's figure this out. What is our actual angle from the positive x-axis? What would that be? 120. Okay. So from east to north is 90, and then we went 30 more. So 120 is the actual angle that we need to use. Okay, so we're going to break this down. We're going to do the airplane. We're going to find its component. Its velocity is 500. We need to find its x component, so we do the cosine of the angle. Its y component is its velocity times the sine of the angle. Now we've got some wind. It is north 45 degrees towards east. Now, I don't know about you, but I feel like my picture is a little cluttered there, especially if I have to start with north. So I'm going to do a separate diagram for my wind. I'm going north 45 degrees towards east. So if I start at north and move towards east, and I go 45 degrees in that direction. Now on this one, you would get really lucky if you just used 45, because 45 is also the angle from the positive x-axis. So if we find the components for the wind, the x component is the velocity of the wind times the cosine of the angle of the wind. The y component is the velocity times the sine of the angle of the wind. So these two forces, the airplane speed plus the wind speed, are combining to give the actual speed of the airplane. So if they're combining, that means we're going to add our x components and we're going to add our y components. Now, here's what I would suggest that you do when you're crunching these numbers in your calculator. When you do 500 cosine of 120 plus 70 cosine of 45, I would suggest you store that as x, because that's your x component of the overall effect. Now, I would write it down too, but I would store it in my calculator, okay, because this is just going to give us the components. 503. Okay, do the same thing with your y's. 500 sine 120 plus 70 sine of 45. Now, you can't store it as x because you stored the x component as x, so you need to store this as y. So alpha 1, you can store it as y. 482.51. Okay. At this point, you need to confirm what quadrant you're in. Negative x, positive y, we are in quadrant 2. Makes sense because our plane is flying in quadrant 2. Now the wind is going to affect it, but it's only a 70-mile-an-hour wind. It's not going to completely push it into another quadrant. Now, it is possible to move to a different quadrant, but we're just going to leave it like that. Okay? We've got the components. We need the actual speed. The actual speed is the magnitude. We need to find the magnitude here. So magnitude, we'll just say the magnitude of A, since we're talking about the airplane, is equal to the square root of the x component squared plus the y component squared. I'm just going to write x and y there because that's what I'm going to do in my calculator. I'm going to do the square root of x squared plus y squared. Because I stored the x component, I stored the y component, there's no point in having to type all that stuff in. Let the calculator do the work. So the actual speed is about 522.51 miles per hour. That wind is adding to the speed of the plane. It's pushing it, so to speak. Let's find our angle. Okay, our angle is equal to the inverse tangent of our y over our x. So again, let the calculator do the work. Inverse tangent, y over x. Now, negative 67 degrees is not in quadrant number 2. It is not in quadrant number 2. We need to use 67 degrees as a reference angle. So we subtract that from 180. Well, guess what? It's the same as adding 180 to it. Okay, that's going to put us in the right quadrant. 112 degrees is in the correct quadrant. So I'm going to write down that we got negative 67.44, but I added 180 to put it in the right quadrant of 112.565 degrees. Now, I'm fine with you leaving the answer like that, but what if this is a multiple choice question and it gives it to you since our original things were in north, whatever, east, and west? How do we put it in that same form? Okay, well, let's go back to our original picture right here. This was north 30 degrees west, and it was 120 degrees. We've got 112 degrees. So if we subtract the 90 from that, we get north. If we subtract 90, north 22.565 degrees west. That is equivalent to 122.565 degrees. So the actual speed, 522.51. The actual direction, either 112.565 or north 22.565 degrees west. Okay, let's do another one because that had a whole bunch of steps to it. An airplane is traveling at 450 miles per hour in the south, 18 degrees east direction when it encounters a wind of 40 miles per hour blowing due west. So let's do our airplane south, 18 degrees east. So we start with south and we move 18 degrees towards east. So 18 goes right here. So our actual angle would be 270 plus 18. $270 is this point right here, so then we go 18 degrees past that.